Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate from the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so question 1 says that most of the sodium chlorate produced in the United States is converted into chlorine dioxide, which is then used for bleaching wood pulp. Sodium chlorate plus 2 moles of hydrochloric acid makes chlorine dioxide plus chlorine gas plus sodium chloride plus water. How many milliliters of 12.1 mole per liter hydrochloric acid is necessary to react completely with 35.09 grams of sodium chlorate? Part B, what is the maximum mass in grams of chlorine dioxide that can be formed from the complete reaction of 65 milliliters of 12.1 mole per liter hydrochloric acid? Okay, so before we try to answer these questions, we first need to write down the balanced chemical equation, which thankfully was already written out for us. It's 1 mole of sodium chlorate plus 2 moles of hydrochloric acid produces 1 mole of chlorine dioxide plus half of Cl2 plus sodium chloride plus water. Okay, so managed to fit it all in one line. And now for part A, how many milliliters of 12.1 mole per liter HCl is necessary to react completely with 35.09 grams of sodium chlorate? So this is part A. And step 1 is to find the number of moles of sodium chlorate. So first let's calculate the molar mass of sodium chlorate. And we know that it's going to be the molar mass of sodium plus the molar mass of chlorine plus 3 times the molar mass of oxygen. Okay, so these are just values that you would find on your periodic table. For sodium, it's 22.99 grams per mole. Chlorine is 35.45 grams per mole. And finally, oxygen's is around 16 grams per mole. So now if we sum these all up, we get a final molar mass of 106.44 grams per mole. So now that we have the molar mass of sodium chlorate, we can calculate the number of moles. So recall that number of moles is equal to mass over molar mass. So the mass was given in the question. It's 35.09 grams. And the molar mass is what we just calculated. So 106.44 grams per mole. Okay, so now our grams will cancel out, and we're left with our units and moles, and you end up with 0.33 moles. Okay, so step 2 is to now find the number of moles of HCl by using molar ratios. So we know that we have 0.33 moles of sodium chlorate, and now we need to multiply by the molar ratio to find the number of moles of HCl. So we know that 2 moles of HCl are needed for every 1 mole of sodium chlorate. And we find the molar ratio by using our balanced equation. And notice that you know you did it correctly if your moles of sodium chlorate cancel out and you're left with the number of moles of HCl. So in this case, we get 0.7865 moles of HCl. So finally, for step 3, we need to find the volume. Find volume of HCl. So if we recall that the concentration is equal to number of moles divided by volume, then we can rearrange this equation to get volume is equal to number of moles divided by concentration. So we found the number of moles to be 0.7865, and the concentration is given in the question. It is 12.1 moles per liter. So now our moles will cancel out and we're left with our liters. So let me pull up a calculator. And you get 0.065 liters, which is the same as 65 milliliters. Okay, so 65 milliliters is needed. Oh, I just realized that I did my first part wrong. So 0.33 times 2 is actually 0.66. I think I was looking ahead, so let me just fix that. So that's just going to affect all of the remaining answers. But we still follow the same steps. And that's why it's always important to show all of your steps, because even if you mess up the calculations, if you show up all of the different steps, you still get part marks for your answer. So now we end up with 0.0545 liters, or 54.5 milliliters. Okay, so that makes more sense. And that was just for part A. So for part B, I'll do it on the next page. What is the maximum mass in grams of the chlorine dioxide that can be formed from the complete reaction of 65 milliliters of 12.1 moles per liter HCl. Okay, so this is a similar question as our previous one. So the first step is to find the number of moles of HCl. So again, concentration is equal to number of moles divided by volume. So to find number of moles, we just need to multiply concentration and volume. And let's convert our volume to liters because our concentration is in moles per liter. And we want the units to cancel out. So 65 milliliters is the same thing as 0.065 liters. Yep. And now our liters will cancel out, and we're left with our number of moles, which is, this is equal to now 0.787 moles. Okay, so for part 2, we now need to use the molar ratios to find the number of moles of chlorine dioxide. So we have 0.787 moles of HCl. And we need to look at our balanced chemical equation. And you'll see that for every 1 mole of chlorine dioxide that's formed, it needed 2 moles of hydrochloric acid. So then we can write out our molar ratio. So 1 mole of chlorine dioxide is formed with every 2 moles of HCl. So then we just divide this value by 2, and you end up with 0.393 moles of ClO2. So now step 3 is to find the mass of chlorine dioxide. And first we need to find out the molar mass of chlorine dioxide, which is just going to be the molar mass of chlorine plus 2 times the molar mass of oxygen. So the molar mass of chlorine and oxygen are just found on the periodic table, 35.45 for chlorine and around 16 for oxygen. And you end up with a molar mass of 67.45 grams per mole. And now we can calculate for the mass, because the mass is just equal to the number of moles times the molar mass. So the number of moles we found in the previous step was 0.393 moles. And the molar mass we just calculated to be 67, I'll just say 67.5 grams per mole. So it can all fit. And we get a final grams of 26.51. Okay, so now let's see what the junior tutor said, starting with part A. First, convert the mass of sodium chlorate to moles of HCl using their stoichiometric ratio given in the balanced equation. And they have the molecular weight of sodium chlorate to be 106.44. So they did it all in one step. They showed 35.09 divided by 106 to get 0.33. And then they multiplied this by 2 to get 0.66. And then they calculated for the volume by dividing number of moles by concentration and got around 55 milliliters. Okay, so now for part B, they found the number of moles of HCl, 0.787 moles, and then converted this to mass by using the stoichiometric ratio as given by the balanced equation. And they also got 26.5-ish. So this solution is correct.